right side, E is approximately a number of 2.718. In the Stone Ages, we estimated that to be 3 because we did everything non-graphing calculator. However, what you're going to be doing is estimating that it was approximately 2.718, or just put it as E in your calculator. A is you could be used as any number. For instance, 7 to the x, so A is 7. 3 to the x, so A is 3. It's anything brought to the power of x. That's what we're using as A. What I'm going to graph right now is y is equal to 2 to the x. What I'm going to do is use the t-chart, which I use quite a bit to graph these. I'm just going to pick the numbers between 0 and 3, and actually go down to -3, so I can get a pretty good visual of what this is going to look like. Well, first thing, 2 to the 0, of course that is 1. 2 to the first, that's 2. 2 squared is 4. 2 to the third is 8. Second one, 2 to the negative first. Let's work down here. That's 1 over 2 to the first, or 1/2. Over here, 2 to the negative second, that's 1 over 2 to the second, or 1/4. As you can see, these are going to be reciprocals, and this last one is going to be 1/8. If I graph this then, which I'm going to go 1, 2, 3, and then the highest number I have is 8. 1, 2, 3, 4, 6, 7, 8. And I get a graph of this. I'm going to start with 3, 8. 2, 1, 2, 3, 4. 1 goes to 2. 0 goes to 1. -1 is 1/2. A quarter. And 1/8. What I can see is a graph that looks like, it actually should be going through here. It looks like it's touching the x-axis, or going closer and closer to the x-axis, and shooting up. So basically, if I wanted to figure out the domain and range, my domain would be all real numbers. So if you write all reals, or from -infinity to infinity, and make sure you have parentheses on there because you can never reach infinity, you're good. The range is going to be 0 to infinity. Because it never quite touches 0, you never get down to 0, but you get really close. It's actually the same thing with E. What I did to save a little bit of time, I graphed all these. I took E to the 0, anything to the 0 is 1. I took E to the negative first. You can check these on your graphing calculator. I came up all the way up to 3 just like before. And then what I did is graphed it. You're going to see our domain and range is exactly the same. Because we're getting closer to the domain, you can put any number in there. The range, it goes from 0 to infinity. So that's the reason I want to show E. And actually all these are going to be the same. If I graph for the domain and range, say y is equal to the 7 to the x, the graphs will look very similar, but the domains and range are going to be the same. Now I'm going to switch a few things and look at the graphs. If I want to find the domain and range of 2 to the x, so we've already done this one. So I'm not going to insult your intelligence. This was our standard graph that we graph. We said the domain was all reals, and the range went from 0 to infinity. However, now what I did is I switched things. First thing I switched, as you can see, that's 2 to the negative x. I don't know what that little line is there for, but it's there. It's 2 to the negative x. You're going to see the domain's the same. The graph looks almost identical, except it's kind of flipped. Instead of starting on the left side and going up, this one starts up on the left side and goes down, which makes sense because you have a negative there. Because if you think of this, if I, for instance, on this left side, take 2 to the negative second if x is equal to -2. Well, that's exactly the same thing as x is equal to 2 on here. That's 2 to, if I put x is equal to the opposite of, that's what it would turn out to be. So this point right here would be exactly the same thing as this point right there, and vice versa. You can kind of look at both of those. All right, now what I'm going to do is break this down. So if I found the domain and range on here, the domain is going to be the same. It's still from -infinity to infinity. All it did is kind of flipped itself. The range is actually going to be the same too, because it starts out at 0, but 0 on the right side, and goes up to infinity on the left side. So that's not going to change that much. where I get something to change from this graph to here, from the opposite of 2 to the x. What it looks like, it's a reflection on the x, which it is. So the domain, once again, is going to be all reals. So negative infinity to infinity. The range is going to change though. It looks like the top is going to be 0 as opposed to the bottom because it's a reflection on that axis. So that's not really changing much. The last thing I'm going to do is I'm going to look at 2 to the x minus 3. What you look at is there's an asymptote 3 lower. So once again, the domain is negative infinity to infinity because you can put in any value. But the range is going to, instead of 0 to infinity, like our first one, this one is going to be negative 3 to infinity because, and it can't be equal to, once again, can't be equal to, so there's a parentheses because it starts in going up. I think this will help you graph everything because all these exponential patterns fit the same. What we're going to do, we're going to break this down, is find the domain and range of 2 other ones. Well, first thing I like doing, I like to get just a visual of what the graph is. I know it says find domain and range as graph. I actually graph first. So what I'm going to do is put in 0. Well, 3 to the 0 is 1. 3 to the first is 3. 3 to the negative first is 1/3. Now I can get a good look at what the graph is going to look like. So let's see. I'm going to go by, it looks like these are 1s on this at 1, 2, 3, 4. Looks like they're going by 10. So 0, 1. Alright. 1 looks like it goes up to 3, and 3 and 1/3. It looks like the graph, and I'm drawing a rough draft. I'm doing this by hand because it says no calculator is going to look like that. So my domain, this is starting to look familiar, is a negative infinity to infinity. My range, which of course is up and down, is 0 to infinity. Same thing as with 2 to the x. That one's kind of a straightforward one. Now let's look at this one. This one's going to be a little bit tougher. I go up 3, so I know that there's going to be something going on. Actually, let's get a very general graph of this. Let's first plug in x is equal to 0. Well, e to the 0 is 1 times negative 2. So that's negative 2 plus 3 is 1. So I know it's going through 0, 1. Rest of these are a little bit harder to do without a calculator. I'm going to have to, I know my graph of e to the x looks like here. But because it's negative, we learned that if it's negative, let me go back here temporarily. Because it's a negative exponent from on this part, it's going to be kind of a reflection. So it's going to be coming down. So let me go over here, go back. So actually, I'm sorry, the negative is in the other place. It's the one down here. So it's a reflection on the x-axis. So it's going to be going down. The negative 2 just affects the slant and makes it steeper. And then the plus 3 from what I'm having. So looks like I'm going to go up 3. I'm just making a dashed line. I'm going to make my final graph in green here. Looks like this is going to be an estimate of the graph. So I did bring everything up 3, and then I reflect it because of that negative. So it looks like I have a fairly decent graph. So make sure I'm right, to make sure I didn't make any stupid errors. And let's take a quick glance. So I have negative 2 to the x minus 3. That looks like I know what I'm doing. Now what I'm going to do is find my domain and range. In this case, my domain, let's see, my domain is going to be, once again, negative infinity because it's going forever to the left and forever to the right. I better put a negative there. My range, it looks like it's negative infinity because it goes forever down, but yet the top is going to be at 3, but it's never going to quite get to 3. And I can put in a few numbers here if I'm not quite sure on my chart to see what that looks like. But that's how you can make a rough estimate of all these. I think that's fairly decent from what we know. Alright, now the next one is going to be you can use your calculators. As you can see on the bottom here, I put a little note. You can use trace, but trace will be a poor estimate, and I want things rounded to 3 decimal places, so you'll probably get them marked wrong. What I recommend is to use where it says right below there's calc. It's a much better estimate, the 0, and then it's going to ask you for the right, the left, and guess. What I did is I drew a picture of my graph What I can see in this first answer, just by looking at it, my answer is going to be between 1 and 2. A 0 is where it crosses the x-axis. So what I'm going to do is, you can probably hear me as I'm playing with my calculator right now. I'm plugging in some numbers. I put in that function, I graphed it. Now I'm pushing second calc. Alright, I graphed that. And it's asking to go to the left of it, so I go somewhere to the left of this function. I put my cursor, push enter. Now it's asking me for the right. Now I go somewhere to the right of here, I push enter. Then it's going to ask me to guess. Well, I get as close as I can to that estimate, and then I find that. So after doing that, what I came up with an answer of is, let's see, this first one I have is 1.3862944. I put all those. Remember, I'm not going to require that. I only require 3 decimal places, so there is approximately my 0, and that's all I do. Same thing for one more complicated. Some of you might prefer to write this so you can see what it looks like as 2 to the x plus 9. You can see it's going up 9 from right here, so that's where the asymptote is, and that makes sense. You can put it in your calculator any way. I'm going to do the same thing just by looking at it. It looks like the answer is going to be somewhere between 3 and 4. So I'm going to do the same thing. You can hear me probably pushing numbers in my calculator right now. Alright, what I came up with is this case 3.169925. I would expect you to round to 3 decimal places, so you do have to show the zeros. So your final answer and find the zeros is 3.170. This is kind of a review of using your graphing calculator. Still not that bad. Third thing we're going to do is rewrite expressions using a different base. I want to start out with something easier and then going on to something a bit more complicated. First one is 27 to the x power. Well, I know I need to write this as base 3. Well, I know 27 is 3 to the third to the x. And I know by multiplying by power to a power, I can multiply those. So my final answer is going to be 3 to the 3x. That's easy enough. That's exactly the same thing as 27 to the x, and I wrote it with the base of 3. I'm done with that. Second one's going to be a little bit tougher. This one says to rewrite this as base 2. Well, first thing I'm thinking of is a negative exponent. For instance, 7 to the negative first is exactly the same thing as 1 over 7 or 1 over 7 to the first. So because of that negative, first thing I'm going to do is rewrite this as 16 to the positive 2x power. Alright, so I dealt with a negative. Well, 16 I know is the same thing as 2 to the fourth. So that is 2 to the fourth to the 2x power. Now I take power to a power to, like I did in last one, and 4 times 2x is 8x. My final answer is 2 to the 8x power. I'm done. So I rewrote that as base 2. Those aren't too difficult. You're going to get 1 or 2 of those on your homework assignment. The last thing we're going to do is go over applications of exponential functions. You're going to see, once again, this is not terribly difficult. I'm going to define what these mean. And all the problems that you're going to be giving, y sub 0 is going to be what you're going to have with as in the beginning. One of these later I'm going to go over is bacteria. Y is what you're going to come up with at the end. So that's what you're going to come up with at the end. E is just the exponential functions. Usually when you're having E there, it's going to occur naturally. For instance, if you're talking about I don't know, decay of something. If, let's for instance, I know this sounds a little grotesque, but if I died and you, instead of calling the authorities, you guys just threw my body out the window, well, I'm going to decay naturally. I'd use E to find out basically how long it would take to decay. K is going to be the rate it decays, and it's usually a constant. It's a little bit tough to figure out. And T is time in years. So we're going to be working on that. The only thing different on this next one, which A is a constant. So for instance, you may have it 2. That will be more clear. And like if something says we're going to have one that we can solve 2 different ways, or you can, if something doubles, that's a 2. But I'm actually going to be using the left one by far more. That's why I spent so much time on it. There's only one difference on here, and that is the what we're going to have is a compound interest formula. The only thing that you need to find over here is the interest rate, and that is a decimal. You have to write that as a decimal. P is still what you begin with. That's actually start with a principal. That's what they call it. N is the number of times per year. And T is time in years. So what I'm going to do is tackle 3 of the examples. You've seen these before in Algebra 2 and a little bit in Pre-Calc. And what we're going to do is tackle a few of these. Let's see what we have. All right, first one we have is I have the amount of silicon-32 in a sample will decay from 28 grams to 7 grams in approximately 300. So I want to know the half-life of it. So the first thing I'm going to do, it looks like it's decaying, so it's naturally. It's actually about the same as I used about throwing my body outside. So first thing I'm going to do is set this up. I'm going to be using this equation. It looks like it ends up at 7. I'm going to be using the calculator for sure. So 7 is equal to 28, e to the 340, and I'm looking for 8k to start out. So 340 years. The first thing I'm going to do is solve for my constant. Well, if I divide by 28, that's going to be 1/4 is equal to e to the 340k. All right. Now what I have to do is get rid of the e because my job is to solve for k. So I'm going to take the natural log of both sides. So I'm going to have the natural log of 1/4 is equal to 340 times k. I have to solve for k, so I'm going to divide by 340. You are going to put this in your calculator and save it. I saved it as k, and this is going to be your k. You're going to come up with a value of approximately 0.00407. Make sure you save that. You don't want to round that. So what I'm going to do is I'm going to put a big red box around that because I'm going to save that as k. What I'm going to do now is use that to figure out the half-life. So what's approximate half-life? Well, I'm going to use this formula again. I already know what k is. So I'm going to come up with e to the k times t. So because I'm going to solve for k. Since I have k stored in my calculator, I'm going to put it as a red k. That's my goal. Well, half-life, you can start, it's just like it sounds, is when you end up with half of it. I use easy numbers. I'm going to start out with 2 and end up with 1. I don't care what you use as long as what you start with is double what you end with. You can start out with 20, end up with 10, but I like to use simple numbers. It's up to you. Our goal is to solve for t. First thing I'm going to do is just use order of operations. I'm going to divide by 2. So I'll have 1/2 e to the k times t. Once again, I'm going to put my k in red because I already have that value. I'm going to take the natural log of both sides, because I need to get rid of that e. So I have the natural log of 1/2 is equal to k times t. I'm going to put that back in red. Then I'm going to divide by k. I already have that state in my calculator. So I'm going to get t is equal to, and it looks like that one turns out to be exact, is 170. So I'm going to answer that as 170 years is the half-life. So at 170 years, I come up with my half-life. That means how many years it's going to take to break it in half of the value. I know there are other ways to do these. I won't mark them wrong as long as your math is correct and I can follow that. So don't go into panic mode if you have a different way of solving this. And so no issue whatsoever as long as you're showing your work. Alright, now what I'm going to do is go a compound interest problem. And then I'm going to go over a problem that you can solve both ways. Compound interest problem, for instance, it told me to use that because it says it's compound monthly. So what I'm going to do over here is try to solve this. I want to double my value. Alright, so in my principal, you can make up anything it doesn't give you. I'm going to use 1. Once again, I want to double it, so I'm going to end up with 2. Alright, so now I'm going to come up with 1 plus my interest rate as a decimal. It says 6.25%, 0.0625, and it's monthly. That means it's 12 times a year. And then I'm going to come up with 12 times, let's see, determine how much time, so that's what I'm solving for t. All right, what I'm going to do is do that. Once again, this is a calculator problem. This would be very hard to do without using a calculator. So I want to double that. All right, first thing I'm going to do is, let's see, I'm going to figure out what this is. What I did is 0.0625 divided by 12, and I added 1 to I saved it, but this is what I came up with. That's not an exact answer, but that is saved on my calculator. I'm going to take the natural log of both sides. Alright, so natural log, the reason I'm doing that is because we learned because of natural logs in previous classes, I can move the exponent out front. Alright, so 1.005208. Alright, my goal is to solve for t, so what I'm going to do is take both of these and I'm going to divide both of these by 12 times the natural log of what I have saved in my calculator. What I actually did is when I came up with this number, I saved that as a. But you can, and if you don't know how to do that, I know I taught my pre-calc students last year how to save, but if you don't know how to save things, you might want to ask, because a lot of times I'm going to save and expect you to know that right away. What I came up with, it says determine how much time. It looks like, let's make sure I have this right. I have this put in my calculator. So it's 11.119, and that's going to be in years. So in 11.119, if that's all true and it's compounded monthly, you're going to double your money. Last one I'm going to go over before we call it a day. I'm going to go over one that you can solve two different ways. Alright, it looks like, suppose a colony of bacteria starts with 1 and doubles every half hour. How many bacteria will the colony contain at the end of 24 hours? Well, there's actually two ways to do this. I'm going to solve it the way I've been doing it. Looks like it's natural, it's doubling. So it's doubling every half hour. So I'm going to be using this formula. So the first thing I'm going to do is it starts out at 1 and doubles every half hour. So e to the 1/2 k. Alright, divide by 1, okay, that's still 2, is equal to e to the 0.5 or 1/2 k. And my goal is to solve for k. I want to find the value of my constant. Take the natural log of both sides. So I'm going to have the natural log of 2 equals 0.5 k, because 1/2 k divided by 0.5, and I'm going to save this later on. I'm going to save this as k. Well, natural log of 2 divided by 0.5 is approximately 1.3886. I'm going to save this though, so on my calculator, that's what I'm reaching for right now. You can probably hear me clicking buttons. Again, I'm going to save that. Now I'm going to go back and use that same formula to find out how many bacteria will be in there. So I need to solve for y. I'm starting out with 1, just like it says. E to the, I have k in my calculator, and I'm going to come up with 24 hours. So times 24. All I'm going to do is put this in my calculator. That's e to the 24 times what I have. I came up with a value of 2.815 times 10 to the 14th bacterium. That is the correct answer. No problem. Someone may say there's an easier way to do that. Since I know it's doubling every half hour, why don't I keep on doing that and just put 2 to the 24th? So I'm sorry, that wouldn't be correct, because it's doubling every half hour. That'd be 2 to the 48th power. Well, yeah, that's another way to do it. You're going to come up with the same answer. I would accept that, because in this problem I want to say that there's a different way to doing that, because it doubles every half hour. So there's 48 half hours in 24 hours, so that would work. That's all I'm going to go over. Hopefully you don't have a lot of trouble going over this. Have a great day. Come on.